Morning, students. Let us begin our today's class on the chapter Is Matter Around Us Pure? In previous class, we were discussing about the concentration of solution. So today we are going to deal with some numerical first on the basis of that topic and then later on some more topics. So today we are going to discuss suspension, its example, along with properties, colloidal solution, examples and its properties, and Tyndall effect. So let us begin. As we are knowing that, student, the concentration of a solution is the amount of solute present in a given amount of solution or the amount of solute dissolved in a given mass or volume of solvent. So concentration of solution will be equals to amount of solute or amount of solution, or we can say amount of solute by amount of solvent. So there are various ways of expressing the concentration of a solution, but here we will learn only two methods, that is mass by mass percentage of a solution or mass by volume percentage of a solution. So in terms of mass by mass, we are having the formula for calculating the concentration of the solution, that will be equals to mass of solute divided by mass of solution multiplied by 100. Again, in terms of mass by volume, the formula we are having is concentration of solution will be equals to mass of solute by volume of solution multiplied with 100. And if we want to calculate the concentration of solution in terms of volume by volume percentage, then what would be our formula? Volume of solute by volume of solution multiplied with 100. So let us proceed towards the first question. So the question is like this: a solution contains 40 gram of common salt in 320 grams of water. So you have to calculate the concentration in terms of mass by mass percentage of the solution. So what have been given to us? 40 gram of common salt and 320 gram of water, means mass of solute and mass of solvent being given to us. So for calculating the mass of solution, we are knowing that we have to add the mass of solute plus solvent. So then we are getting 40 gram plus 320 grams, that will be equals to 360 grams. So we have got mass of solution. So applying the formula of mass by mass percentage of a solution, we are having mass of solute 40 gram divided by mass of solution 360 gram multiplied with 100. And after calculating this, we are getting the concentration of the solution is 11.1% in terms of mass by mass. So I hope it's clear to all of you. Let us one more question. So question is, 5 gram of sugar is dissolved in 250 ml of solution. So you have to calculate its mass percent by volume. So I hope question is clear to all of you. So we have been given mass of solute and volume of solution. So we are going to apply mass by volume percentage of a solution will be equals to mass of solute by volume of solution multiplied with 100. So we have applied 50 divided by 250 multiplied with 100. So we are getting 2%. So that is the concentration of the solution in terms of mass by volume. So I hope now for finding the concentration of solution, it's clear to all of you. So let us proceed further towards our next topic, that is suspension. So suspension, what is suspension? First of all, suspension lies under the category of heterogeneous mixture. So suspension is a heterogeneous mixture in which The solute particles do not dissolve but remain suspended throughout the bulk of the medium. So particles of a suspension are visible to the naked eye. For example, if we are considering the mixture of sand and water, obviously it's an example of suspension. You can see some more examples of suspension: muddy water, nail polish, squashes, the smoke coming from chimneys, it is containing dust particles, the juices, it is also containing some suspended particles of the food. So these all are the examples of suspension. So let us proceed further towards the properties of suspension. So what are the properties of suspension? So suspension, first of all, is a heterogeneous mixture. Secondly, the particles of a suspension can be seen by naked eye. We are able to see the particles of the suspension. Now moving further, the particles of a suspension scatter a beam of light passing through it and make its path visible. Why? Because the particles are larger enough of the suspension so that the beam of light passing through the suspension may be scattered. Now further, the solute particles settle down when a suspension is left undisturbed. That is, a suspension is an unstable solution or unstable mixture, we can say. So the next one, they can be separated from the mixture by the process of filtration. Means we can separate the components of the mixture of suspension by the process of filtration. So these are some of the properties of suspension. So I hope suspension is clear to all of you. So moving towards the next topic, that is colloidal solution. So students, what is colloidal solution? It is actually a heterogeneous mixture. The particles of a colloid are uniformly spread throughout the solution. And due to the relatively smaller size of particles as compared to that of a suspension, the mixture appears to be homogeneous, but in actually it is a heterogeneous mixture. So we can say that, but actually a colloidal solution is a heterogeneous mixture. For example, you can see milk. If we are considering milk, so milk seems to be homogeneous, but it is actually a heterogeneous mixture, like fat and proteins are suspended in it. So now there are some more examples of colloids. You can see over here colloidal solution: foams, fog, smoke, aerogel, blood, paints. So these are some other examples of colloidal solution, and we can categorize these examples depending upon the state of dispersing medium and the dispersed phase. Now, what are these two new terms? Dispersion medium and dispersed phase. Basically, we say that these two are the components of colloidal solution. So, let us discuss about the components of colloidal solution. So the components of a colloidal solution are the dispersed phase and dispersion medium. So the solute-like component or the dispersed particles in a colloid form the dispersed phase, and the component in which the dispersed phase is suspended is known as dispersing medium. And colloids are classified according to the state, that is solid, liquid or gas, of the dispersing medium and the dispersed phase. So a few common examples you can see, these are given in the table and these have been taken from your everyday life, and dispersing medium and dispersed phase are also being given. So you can see over here the first one, dispersed phase, liquid and gas. It is the type of aerosol. So examples are fog, cloud, mist. Again, the secondly, we can say aerosol, another type of aerosol in which solid is the dispersed phase and gas is the dispersing medium. So example, smoke, automobile exhaust, all those are aerosols. Now for example, if we are considering shaving cream, so it is a type of foam. It is also a type of colloids. So in foam, we can say that gas is the dispersed phase and liquid is the dispersing medium. And if we are considering milk, milk is an emulsion, is a type of colloid and it is liquid in liquid. And for if we are considering milk of magnesia or mud, then it is a type of sol, SOL. And here the dispersed phase is solid and the dispersing medium is liquid. And further, if we are considering foam type of colloids, then examples are rubber, sponge, pumice stone, foam. So here the dispersed phase is gas and dispersing medium is solid. Again, if you are considering jelly, cheese, butter, all these things, then it is a type of gel in which liquid and solid. Now again, lastly, if we are considering colored gemstone, milky glass, ruby glass, then it is a type of solid sol, where dispersed phase is solid and dispersing medium is also solid. So these are the types of colloids. We can say these are the 8 types of colloids depending upon the dispersed phase and dispersing medium. So I hope you can remember all these types of colloids. So moving further towards the properties of colloids. So what are the properties of colloid? A colloid is a heterogeneous mixture. First of all, further, the size of particles of a colloid is too small to be individually seen by naked eyes. Means we are not able to see the particles of a colloid. Further, colloids are big enough to scatter a beam of light passing through it and make its path visible. We can say that like particles of colloid are small that we cannot see it through naked eye, but those are not too small that they cannot scatter a beam of light passing through it. Means colloids are big enough to scatter a beam of light passing through it. Next, they do not settle down when left undisturbed. That means colloid is a stable solution. Now, further, they cannot be separated from the mixture by the process of filtration. Means we can't filter out the fats and protein from milk, obviously. So that's why we can say that a special technique of separation known as centrifugation can be used to separate the colloidal particles. Like centrifugation and some other processes as well. So we need to apply some special techniques for their separation. So this is all about the suspension and colloids. So I hope you have understood it. So one more important topic, that is Tyndall effect. So first of all, student, this Tyndall effect was first discovered by an Irish physicist, John Tyndall. And what he said that when a beam of light passes through a colloid or a colloidal solution, the colloidal particles present in the solution do not allow the beam to completely pass through. So the light colloids with the colloidal particles and is scattered. And this scattering makes the path of the light beam visible, as you can see over here in the picture. The Tyndall effect is being shown. Light source is the torch and we are having solution, colloid and suspension. You can see over here the light beam is not visible through solution, means this phenomena is not being shown by solution, but it is shown by colloidal solution. Like if you are considering milk, then the path is visible, then the beam of light is being scattered because the particles of colloids are big enough to scatter. Again, same for suspension. Now, some examples we can consider for Tyndall effect, like milk is a colloid that contains globules of fat and protein. So when a beam of light is directed at a glass of milk, the light is scattered. So this is a great example of Tyndall effect. Or you must have seen students when sunlight passes through the canopy of a dense forest. You can see over here in the diagram also, the canopy, yeah, is shown over here. So in the forest, mist contains the tiny droplets of water, which acts as particles of colloid dispersed in air. So you can see over here Tyndall effect is being shown. Again, if you want to cite more example, then you can observe Tyndall effect when a fine beam of light entering into a room through a small hole. So there also the Tyndall effect is taking place due to scattering of light, and scattering of light is being taking place by the particles of dust and smoke in the air, and then you are able to see the path, you are able to see the light, and you are able to see those particles which is present in air. So these are the examples of Tyndall effect, and we can say that Tyndall effect can be observed in colloidal solution and suspension as well. So today we have discussed about suspension, colloidal solution and Tyndall effect. We had also done two numericals for calculation of concentration of a solution. So I hope you have understood till now. So thank you students.